Hello. Today we're going to take a look at confidence intervals. Now the definition for confidence interval there is a range of values used to estimate a population parameter with a given level of confidence. Now remember, what we're trying to do here is we're trying to estimate or give an educated guess, if you will, about a population. And we're really only going to be able to use a sample in order to do so. So we're going to take this sample data and we're going to use it to make an estimate about a population parameter, whether that be the mean, a proportion, standard deviation, and so on. So down in the bottom I have an example here that says that the average salary at the Hart Company is between $65,100 and $78,300 with 95% confidence. So although I haven't shown you how to do this, this is what we would be looking to do. We have taken a sample of people that worked at the Hart Company. We have found the average of that sample, and then we made a prediction about all the people that work at the Hart Company. Now notice that we have a 95% confidence. Now, when our confidence changes, our sample or our confidence interval is going to change. Here you can see that I have a 99% confidence interval, but I've had to change the salary from $64,200 to $79,800. I got more confident with this second example, but I also had to increase the range of my values in order to do so. So confidence levels is kind of like throwing, or confidence levels or intervals is kind of like throwing a ball at a wall. Okay, if I take myself and I put myself 25 feet away from a wall, okay, and I throw the ball. Now I have a pretty good level of confidence, let's say about 99%, that I could probably actually take this ball in my hand, and you got to humor my drawing here, but I probably could throw it and hit the wall. I'm fairly confident that I could do that. And remember, all I got to do is hit the wall. It doesn't matter if I hit it up way up high or down low. So I only need to hit the wall. So again, my confidence of doing so is about 99%. Now, what happens if I change this scenario and I say, well, now I'm the same distance away, but I need to hit a target that's only 2 feet by 2 feet. So here's my changed. Now, I'm probably not going to be as confident in doing that, okay, because I probably sometimes will be able to hit the target pretty well, but there are other times that I'll probably throw it too high, or maybe I'll throw it too low. And so the thing that happens, though, is if I do throw this ball from 25 feet and hit the target, I'm very precise. Not only do I not just have to hit the wall, but I have to hit a specific target on that wall. And this is why confidence intervals are just like this. Okay? The more confident we are, the less precise we're going to be, and the less confident we are, the wider range we're going to have. And I've kind of summarized this in this little sort of chart here, I guess. When your confidence goes up, the interval is going to be much wider, but your precision is going to go down. And this is like the very first example that I said here, is when I'm throwing the ball and all I have to do is hit the wall. So just think of this as just hit the wall. Okay? My confidence is going to be very high. The interval is going to be really wide because it's just the whole wall. But my precision is going to be down because I can hit the wall anywhere. In example 2 of my throwing the ball, okay, now I got to hit a target. So my confidence is going to go down. The interval is really narrow because I only win if I hit the target. But my precision is really up because if I hit it, boy, I hit a really small little area of the wall. So this kind of little chart is almost very important for us to realize when we talk about confidence intervals. Okay, precision goes down when confidence goes up, and precision goes up when confidence goes down. So these are important things to do. So make sure you look at this table and kind of get an idea of what's going on here. Okay, now all confidence levels are based on a probability distribution. Well, we've been talking about probability distributions, and if you can humor my drawing down here, you can probably see that this is going to be sort of looks like the normal curve that we've been talking about. Well, what happens here? We take a lower limit of our confidence interval and an upper limit of our confidence interval. So these are the two areas, or the two targets area that we have to hit, if you will. And the probability that's in between that and under the curve is our confidence level. So that probability is our confidence level. Now, we've been doing this, so we should have a little bit of familiarity with this. Okay, we've been finding areas under a curve using the normal distribution calculator, and so things like that. So we've given you two numbers, and then you find the area under the curve, or the probability of that particular interval. Well, that's all a confidence interval is, but now we're going to formalize it. And in this video, we're not necessarily worried about how to calculate these yet. That'll be the next video. But in this video, we're just trying to understand what a confidence interval is. So let's look at another little example here. Let's suppose that I'm trying to estimate the mean weight of college football players in the United States. Now, these are all college football players. And I feel that 95% confidence will be enough to cover this estimate. Well, I certainly can't take and do all of my college football players. It just won't be possible. But I could take a small sample of those college football players. And from that sample, I could find the sample mean, okay? And then I could decide that I need a certain probability. And in this case, I'm going to decide that I want to be 95% confidence. So my probability here is going to be 95%. And again, same as 0.95. Now, what I then have to do is I have to decide, well, what's my lower limit and my upper limit in order that I can give you an interval so that I'll have 95% confidence, or this area of the curve that we're talking about right here, okay, will add up to be 95% probability. Again, we're going to do this more formally as we go with some mathematics. But for right now, let's say that I did the calculations. And when I did the calculations, I found out that the lower level of my confidence interval is 195. And the upper level of my confidence interval is 345. So now what I could say is, with 95% confidence, I think the population mean, or the mean of all of the football players in the United States for weight, is going to be somewhere between 195 and 345. Okay? Now, with a little bit of arithmetic, okay, and the idea that this is supposed to be symmetric, what's on the left-hand side should be the same as what's on the right-hand side, we can figure out what that mean will actually be. And here's how we do it. Notice that 75 pounds is on either side of the sample mean. Well, how do I know that? Well, I take the upper limit and I subtract the lower limit. Okay, and when I do that, I get 150. And if I divide that by 2, and that's the symmetric portion, the same amount's going to be on the left as it is on the right, I get 75. And as all confidence intervals are symmetric, I know that I have 75 on each side. This distance, this 75 here, is known as the standard error of my confidence interval, or the radius. Either one is a synonym, okay? So when people say, what's the standard error? Well, it's how much on either side of the sample mean makes up the confidence interval. So what I can say here is that I am 95% confident that the true mean of all football players in the United States will lie somewhere between 195 and 345. And this is the way we normally write confidence intervals, kind of in these inside parentheses with a comma between them. Another way to write this is to just give what we think the mean is, and then the plus or minus 75 pounds. And I'm sure we've all seen on some ad or something like that, they'll say that the one thing you'll see a lot is that a presidential candidate has 68% of the vote in a certain state, and then they'll put a plus or minus 3% on either side of that. Well, they're basically giving you a confidence interval that they estimate that 68% of the people are going to vote for a candidate Bush plus or minus 3%. That's their confidence interval. Okay? So if they were to write this down with the parentheses, what you'd see is they would say that we think the percentage of people that are going to vote for president or for candidate Bush would be between 65 and 71%. And so both of these things are exactly the same. Okay? So most of the time on TV news, this is the one you'll hear, but in a lot of statistical papers and research, this is the one that they'll use for that. Okay, so that's an introduction to confidence intervals. I'll have another video on how to actually calculate them, but get an idea of what these are so that when we start to do the calculations, you understand it.